So I start. Hi, everybody. For all of you who don't know me, because I don't come very often to the university, my name is Alejandra Martin, and I'm a first-year industrial PhD student, and I'm here to talk to you about my PhD topic. So because this is an industrial PhD, it doesn't make sense to start this presentation without a shout out from my sponsors, Flight Keys. So I guess none of you knows what Flight Keys is. I definitely did not before my CB got the first round of interviews approved. Flight Keys is a flight planning software company. It's based in Vienna and it was founded in 2015. We offer flight management solutions to airlines all around the world, mostly in the US, Europe, and Asia Pacific. We have several products, pre-flight, in-flight, and rain predictions. These are called Space Keys, Flight Keys, and Sky Keys. Our main core product, though, is Flight Keys. That's the name. And this is the one that we're going to be using for the industrial PhD. So what are we doing here? Abul Faisal has already given an introduction to it, but I'm going to go over it very quickly because it makes sense for the purpose of the presentation. So imagine we're flying an aircraft during the day and it's generating a contrail. This has two effects. On the one hand, it has a cooling effect because part of the radiation is returned back to space. On the other hand, it also has a warming effect because the same way it's able to reflect radiation back to space, it's also able to reflect radiation right back to the Earth. The overall effect of this cooling and warming can be either positive or negative for a specific flight during the day. But during the night, when we completely eliminate the cooling effect, the overall effect is warming. And we can say that throughout the day, the effect of contrails in this specific example is going to be warming. So you may ask yourselves, why do we care about this? Well, we care about this because according to recent studies, contrails and non-CO2 effects are actually responsible for 2/3 of the total aviation radiative forcing or total aviation climate impact. So the question that we're going to ask ourselves is, how can we tackle this? Can we actually avoid non-CO2 effects through the use of eco-friendly flight planning? So what are we bringing, or Flight Keys and myself, to the table in this matter? Because I'm no genius, I didn't come up with that question. Actually, there has already been many studies that tackled these specific issues. Most of them considered free route airspace, and Abul Faisal recently published a paper about structured airspace. This is the last one from the list. These are just some examples. But the thing that Flight Keys and I are gonna introduce to the table is the practical implementation. So we are a commercial company, we work with real airlines, and Manuel and myself thought it would be interesting to see, is it possible to implement these non-CO2 prediction models into a real commercial flight planning system? And most importantly for our customers, how much will it cost for them? So my industrial PhD has three main objectives. The first one, and the one that I'm currently working on, is the actual implementation of these prediction models into our system. We have already successfully implemented COSIP, which is a control prediction model developed by DLR. And now we're working with the ACCFs, which is a model developed by Abul Faisal, Manuel, and also DLR, because DLR is everywhere. And we hope to have a paper published by September 2023 on these two models and hopefully being able to compare the results between the two of them. The next objective would be to define an experiment where we can actually come up with the conclusion of cost and operational implications of applying non-CO2 avoidance strategies for the airlines. We will be using climate cost functions, and yes, and the experiment is still to be defined, but the idea would be to set up a large case scenario, maybe with some of Flight Keys' real customers throughout the scope of a year or several seasons, several days of the week, and so forth. And the last one is, with the results of this experiment, came up with a proposal of climate implementation for operators and policymakers. So I'm still a first-year student, so we still have a long road ahead of us. But that is overall the overview of my presentation. This is a very cool video. In my company, we have several pilots working also there, and one of us gave us this amazing view of a contrail from the cockpit. And yes, so if any questions, bring them forward.